Hello, everyone, and welcome back to the climate track of PAW. I'm David Rolnick, one of the organizers of PAW Climate, and it's my pleasure to kick off the next round of talks. Our first talk is by Dr. Daniel Rohr of Trax. Trax is a Berlin-based company that uses AI to improve the efficiency of truck-based freight transport, which is currently responsible for about 6% of the EU's CO2 emissions. Dr. Daniel Rohr heads the data science team at Trax. He holds a PhD in physics from VU Amsterdam and worked on fundamental research in quantum chemistry for more than 10 years, managing international teams of researchers on quantitative modeling projects. Thank you so much for joining us. And I'm really excited to hear what you're going to tell us about Trax and trucks and how machine learning can hopefully make things a bit better.
All right, well, thanks a lot for the very kind introduction, and thanks a lot for having me here at the conference, giving me the opportunity to speak. I thought I started the whole session with a small poll, because I've been introduced and I just wanted to have kind of an overview of who you guys are. So maybe you can participate here as a coder, manager, a CO2 saver, or anything else. I'm just curious what your, what your background is. Maybe we wait a few seconds and allow everybody to give their poll. And meanwhile, I show again an short summary slide of myself. I don't know, the team, do we have the poll in? Can we disclose the numbers? I'd be curious to hear. Nikki, can you? Because I cannot see anything here. Now I can see it. All right, good. All right. Looks like we have more coders and managers and not so many CO2 savers. All right, the introduction you heard already. My background is actually in quantum chemistry, and I've been working now for a year and a half for Trax. And the Trax company we are now 3 years old, and we are an AI company. This is our main focus. This is what we want to do. We are a startup with so far 15 employees. We are headquartered in Berlin, in Germany, and we have a mission, as every good startup has a mission, and this is to increase the efficiency and save resources in the road freight industry. So we look into trucks and try to help them save fuel, basically. This saves them money, and of course it saves the whole planet CO2 emissions. And this is what we're striving at. Just to give you kind of an idea of CO2 emissions in general. Typically, this is now we're looking at a reporting company here, let's say in green, and they have a number of different ways how they can emit CO2. So they can, what is called scope 1, this is their direct emissions. So it comes from, from their houses and from their own company vehicles and whatever they want to use for their production. That is kind of scope 1. Scope 2 is the indirect, that's basically electricity. And there, obviously, it depends on what the source of your electricity is, whether you're burning, let's say, coal, fossil fuels, or whether you're using green energy like solar or wind energy or others. And finally, there's scope 3, which is what they call the indirect emissions. And this is mostly upstream and downstream. And here, it turns out that the freight industry on both sides obviously contributes a very large percentage of the overall CO2 emissions for all the industry. And as this is the case, this is what we wanted to tackle. And to start with, though, here, Nikki, could you please also open the second poll here? So the TRAC's mission is to increase the efficiency in the road freight industry. When I was faced with that mission as a data science, I thought to myself, okay, what is efficiency? Like, could I possibly measure that? Is that something that I have a handle for? And so this is the first question that we actually asked ourselves: how can we measure efficiency? In the industry, a lot of people use just the consumption rate. So that's the fuel by distance. Or some people can also use something that they call the intensity, which would be the weight of the cargo times the distance it needs to be transported, and then divided by the fuel. And this will then tell them whether they are efficient or not. From our perspective, it was really not quite so simple, because we thought, okay, what if you're going uphill and against the wind? Then obviously you will use a lot more fuel, and that is not really it's not mirrored in the consumption rate or in the intensity rate as defined here. So the question is, how else could we possibly how else could we kind of try to measure the efficiency? And this is what I would like to invite you to think about. And this is how we started the whole approach. We said we're going to go through a thought experiment, right? And in the thought experiment, we have no boundaries whatsoever, no time limits, no money limits, we can do anything we want. And so, I had a trip with my truck, let's say from Vegas to San Francisco, and I consumed, let's say, 20 gallons. And the question is, was that really efficient? And we came up with the idea that we take all possible trucks that are available on the planet, and we let them drive the exact same tour. And what we mean with exact same tour is like really the exact same conditions, right? The weather is identical, and the traffic is identical, and obviously the weight is identical. And the only thing we change is the truck itself, right? We take a different truck. And then we let all these trucks drive on that particular trip, let's say here in our case from Vegas to San Francisco. And then we see how many gallons each one of those trucks have consumed. And then we can compare. So here's this example, right? My truck had a consumption of 100. And let's say the other trucks, and for the purpose of this example, there's only 4 other trucks. They had the other consumptions that are listed here in the table. So if I have this as my general idea, then I would say, okay, I was rather efficient because I only used 100 liters. The best one, 99, so that's almost the same. But the other 3, they really used, they consumed more fuel than I did. So I want to say my truck and my driving was pretty efficient. If we do this, of course, with many, many trucks, then we will get something like a normal distribution that is symbolized here with a curve. And there's basically, let's say, 3 different points where I can find myself. I can find myself on the left end here on this tail. And then I would think that my truck was efficient, because the way I read it is my truck used this much fuel, these trucks used that much fuel, and so on and so forth. And here, this truck used like really a lot of fuel. There's only a few trucks that used less fuel than me, and there's many that used more fuel than me. That's why I think my truck was efficient. If my truck is around here, somewhere here in this area, well, that means basically my truck was mediocre. And if my truck was somewhere here in this end of the tail, then that basically tells me that my truck was rather inefficient. This is how we kind of define efficiency for trucks. And here I'm interested to see what your thoughts are. Nikki, if you could have, how would you rate this solution, right? How convincing is it for you to say, okay, what is efficiency? Give it just a star rating, 1, 2, 3, 4, 5 stars. And let's see what you think. Now, obviously, this is not the end of everything, but that was the beginning. And at that moment, or right now where we are in this presentation, is like we haven't used any AI, and it's not really clear where the AI even comes in. But it gives us at least a first handle on the question, okay, what is efficiency, right? Okay, and then obviously we want to go further and talk about how to improve efficiency and so on. All right, so I see a few votes. Not everybody is convinced, but there's also no 1 and 2 stars so far, so that's a good thing. All right, let's see. Maybe I can convince you some further. All right, so after this thought experiment, let's go back to the business questions that I wanted to also pose at the beginning. Was I efficient? Basically, we can categorize these business questions in 3 types. We can talk about descriptive, prescriptive, and optimization questions. Right? The descriptive is what has happened. The prescriptive is what could happen, and the optimization is, of course, well, what should happen, right? I have something that I want to happen, so I want to optimize for that to happen. And the way we look at this is analysis, decision, and execution. And obviously, we are today, and so it falls into 2 blocks, right? We have a descriptive block, which is obviously in the past. And we have the 2 other blocks, the prescription and the optimization, which are obviously in the future. All right. Good. So those are the business questions that we would like to answer, but obviously we want to also do some machine learning. And for that machine learning, I'd like to invite you here for the machine learning poll. Nikki, that's, I think, the final poll. I wrote down the variable truck data that we get from what is called telematic systems. So modern trucks, as they come out of the factory, they have a number of sensors already included, and these sensors send signals through SIM cards basically all the time, and we collect them and then use them for our AI. I wrote down the typical variable truck data. What is, for example, interesting, if you note here, there's 3 times speed, right? There's 3 different types of speed that you can get. But what I was, for example, amazed, I didn't think they would even have the pedal position, telling you how low the pedal of the gas pedal is that the driver is driving there. Obviously, the gear, GPS, weight, trailer, driver. There's many different things that we use to then obviously to predict the fuel consumption. And we use a neural net to do the prediction because we think that this regression situation is just the best solution will be a neural net. I saw that one of you also answered a recurring neural net, trying to make use of the time series. We have thought about that, but it didn't turn out to have a very good result for us, so we stuck obviously with the neural net. This is just a picture here that I show you. I assume you're familiar with neural nets. And I just want to show you that obviously we have a few hidden layers, and then we have the features of the variable truck. But that's not all. We need more than those features of the truck. We need extra features. So one of the extra features could be, let's say, the truck's permanent data, right? Like the type. I'm sorry. So is it an MAN? Is it a Daimler truck? Is it a Volvo truck? Is it, I don't know what type of truck? What type of fuel is it using, right? Can be diesel, can be something else. Let's say what type of tires it has. there's other categories that go in here, say a spoiler or other equipment that the truck might use. And we abstract those inputs into, let's say, one or maybe two features that is depicted here by this picture. Similarly, we do the same for the road, right? For the road, we also have different types. If you want, maybe you have a limited access highway, or it's just a suburban street, and that makes a difference, obviously, for your consumption. Construction, the quality of the road. Has it been recently paved, or are there many potholes? A number of things that go into this. And again, we do kind of an abstraction of all this input and end up with one or two features for our final neural net. You can think of this also as a type of embedding if you want, but obviously it's not a word embedding. All right, so once we have these abstractions, then this is how our neural net basically looks. We have here the features, variable truck data, permanent truck data, road, weather, and driver. These are all different categories that kind of describe our current situation for the truck. And we feed the neural net with these features, and we get a final answer, a target value, which tells us how much fuel will be consumed or should be consumed. All right, so this is kind of the technical stuff of our AI. And now what do we do with it, right? So we want to do these three types, and we seem to have a bit of a problem, right? Because if we want to do just the description, that's nice. We have all the information, we have all the data. But if we want to do the prescription, then the problem is that, for example, wheel-based speed or the engine speed or also the gear that the driver is driving in is not information that is available to us before the truck goes on a trip. So to make actual future predictions, actual prescriptions, we have to think about how we do that. And in our case, we decided to actually use another neural net to kind of predict these values. Now, it's one approach. We also tried, let's say, more statistical approach by just taking, for example, the speed of all the trucks that had come across a particular point, and then just taking a statistical value from that. Currently, we believe that's a bit easier to try to predict these speeds, for example, the gear or any other variable feature for the truck. And this is then to produce the features for the truck, and then in order to produce the fuel consumption. So this is basically to allow us not only a description where we have all these values, but it is to allow us also a prescription where we do not have the values like speed and gear. Ultimately, obviously, we want to optimize these things. Okay. Now, since we have all that, this is our, let's say, experimental setup. We have a set of trucks, right? I'm working with a fleet owner, and the fleet owner has these trucks. And the fleet owner only has Alice, Bob, and Sarah to drive. And there's these three different tours that were driven. So all this is on the descriptive part. This is all from yesterday. And now if we want to analyze whether Alice did a good job on driving with her truck on this tour, we will just compare Alice's consumption with all other combinations. So Bob with this truck on this tour, Bob with this truck on this tour, Bob with this truck on this tour. Also Alice with this truck on this tour, Alice with this truck on this tour, and Cyril with all three trucks on this tour. Now, they all share that we kind of have the models predict on the same tour. And there's one combination, this truck with Alice, that actually went on the tour and collected all the information. All other combinations, they just run on the data that has been collected by Alice in her truck on this particular tour. And then once we do that, it allows us just to answer a number of different questions. Similarly, we can do the same thing, of course, for the prescription, right? We can have a number of trucks that may or may not be included in our fleet. We have a number of drivers that may or may not be included in our drivers in staff. And then we have a number of routes that we need to go. And then what we do again, any combination will just be simulated in order to then get the best combination to drive on a particular route. And this will be kind of the optimization step. Once we fulfill that and our customer is actually using that, then we go back to the description, of course, right? Because we predicted something, they executed, and now we're going to analyze whether that went well or not. Now, there's a number of questions that we can ask ourselves, or actually the business owner usually asks themselves. And I would like to just explain quickly how we then try to answer those questions. So on the descriptive end, what has happened, we started with the question, how efficient was I? And I think I was trying to explain that the efficiency of yourself is basically something relative to the other people. Now, the next question is, of course, somebody would like to ask, well, how much could I have saved, right? Is it even worth the effort? I might be really bad, but if I'm saving only, let's say, 0.1%, that's not worth it, right? So the question that I would like to ask, okay, how much could I have saved? And this is how you answer it. You take your trip that you went on, you measure how much you have actually consumed, and then you do the simulation with all the different combinations. And then you see, okay, I was here. So that means mediocre, but how much could I have saved? And the answer is, well, you could have saved this difference here, right? Because there are trucks that saved only that consumed only that much, or even less, or whatever. Usually we try to take a value around here because obviously there might be outliers or just the perfect match. But still, I think it is reasonable to assume that, you can achieve something around here. And so you have an idea of how much could you have saved. The next question that you can ask yourself is, of course, okay, if I could have saved whatever, let's say 10%, or I don't know, well, how can I actually save it, right? I need to know, what should I do? And I can ask the same question and ask, okay, what should I avoid? Okay, what's hurting me and what's good for me? Same thing again. How can I save? I'll look at how I performed, and then I will just look at those trucks that perform very well, or those combinations that perform very well, and try to find out what's unique for these trucks, right? Maybe most of them have a tail fin, let's say, right? Or they are all a particular type of, particular brand, right? Or there's something totally different that I'm not thinking about right now, okay? So this is how we look at in these things, and then we will find out a number of suggestions and say, okay, at least what we see in the data, these types of trucks, they just perform better. Similarly, if I want to understand, okay, what should I avoid? What is hurting me? I will look at the tail end here, right? And I will look at all the trucks that perform badly here, and I will see, okay, maybe it's the tire pressure, or it's the brand of tires, or it's, I don't know. There's a number of things that can happen. And again, this is information that I get for my behavior or my driving on my road, on my trip. So even though I was maybe even good, right? Even if my performance was rather well, I could still look at, what was hurting the other trucks and say, okay, that's at least a hint for me where not to go. Okay. Finally, there's an optimization idea, obviously, that we can think about, and that's what is the best dispatch, right? So tomorrow I have two routes to go, the north route and the south route. And let's say I have two trucks, the red truck and the blue truck, and I have two drivers, Alice and Bob. Which driver should go on which truck on which trip? That would be like the typical question that I want to answer here. How do we do this? Well, we use, again, our neural net, and we take all these features that are that we have, let's say for the variable truck data, for the trip, right? We know which trips, we know the road, and we can have kind of a weather forecast. And then what we do is once we plug in the permanent truck data of the blue truck together with the data of driver Alice, then we take the blue truck with Bob, and then the red truck with Alice, and the red truck with Bob. And all these different combinations and simulations, they will yield us different numbers. And finally, we have like an optimal staffing and optimal dispatch. So we will say, let the blue truck go on the north route with Alice as driver, and Bob takes the red truck on the south route. And this will just be the most efficient for you. Now, these are the things that that we're looking at from a business perspective, and that is really something that was important for us, that we start with the business questions and try to answer those, and not start with data or anything. Now, what we do then after looking at the business questions, we do the design of our experiments. And understand what we actually want to do, what we want to model, and then have only a look at how we do it. Then only we train and test the ML models. And then obviously what we really want to do is we want to optimize the operations. There's a take-home messages, or let's say maybe it's the philosophy of the data science team at Trax, that we say natural intelligence is more important than artificial intelligence. This is really to say, okay, we analyze the problem first without even thinking about machine learning models or anything. And I thought that was kind of resembled in this lecture today with the idea of what is efficiency, right? There was no artificial intelligence that was helping us with this answer. We really thought about it first. And that's how we tackle the problems. The second thing is science versus data. Here again, we take this approach of first trying to make sense of the data in a, let's say, more analytical way, and understanding really what the data says, and really spending time, also maybe doing some feature engineering that plays into that. But definitely we want to understand the problem first. Before we really look at the data. Obviously we just look at the data at the column heads, right? And we're not looking really at the data. And finally, there's something that we like to say is whiteboard before keyboard. That means that we rather discuss things first and make a good plan, or analyze the things on the whiteboard before we start coding. Coding we do once we understand what we want to do. That's a tool then after we kind of found our way, or we think we found our way to where we want to get to. All right. With this, I'd like to thank you for your attention, and I'm happy to take any questions if you have any. Please let me know.
As I try to work out how to turn on my camera. There we go. Thank you so much for that really fantastic talk. I feel like I learned a lot, and I have a bunch of questions myself. While the audience is potentially asking questions in the hop-in, and I encourage everybody to drop questions in the Q&A, I have a few. Which I'm really interested in hearing your thoughts on. So I guess the first question is, it looks like what you're doing technically is a lot of sort of combinatorial reassortment of different possibilities. And I was wondering what your thoughts were on interpretable models, whether those are neural networks or models that actually like have some kind of Bayesian statistics built in, so that one can really pinpoint the effects of different factors without having to do that. Obviously, like if you have a relatively small number of factors, it's fairly cheap to do, but being able to quantify it, like in a Bayesian way would be great. And having interpretability when there are more factors is probably like, I'm just interested in your thoughts on that.
Yeah, no, I understand what you're asking. So, I mean, you use one word, of course, interpretable. I'm sorry, I'm really bad at this. AI that you can interpret. That is definitely a big thing right now. For us, it's really important because we want to give our customers a real benefit. And if you want to give them a real benefit, then obviously you have to tell them why or what, right? If you're not able to do that, then there's not really a benefit for them. So I think in our case, we have both things. We have a bit of why, right, or what, and we have a bit of we don't know why or what. The good thing, or where we do have a why or what, is if we can say, okay, use Alice and the red truck and not Bob and the blue truck, then that is very interpretable, right? You know, okay, do this, do that, and okay, that's very simple. But if it then comes down to more, okay, why is the red truck better than the blue truck, right? Then we are left a bit more with the statistics and look at all the trucks that we look at, and we say, oh, we see just a large group of, let's just say, Daimler trucks, right, that are performing well, whereas a large group of other type of trucks are performing badly. And this is always in relation to a particular trip, right? This is not a general statement. It's not saying Daimler trucks are always bad or good. It's just saying on this particular trip, maybe because it's hilly, right? Maybe it's something else. So, of course, we would like to also improve that and give better ideas or stricter, more direct ideas to our customers, what to improve, how to improve. But I think we have already quite a good handle at these things. Yeah.
No, that absolutely makes sense. And I really like the model of taking everything in a really personalized way and very, very clearly actionable. Yeah, do you have plans to move from Alice versus Bob to sort of characteristics of different drivers? Or is it always going to be like, I mean, it makes sense to be looking at individual drivers because you can't necessarily summarize a person.
Yeah, I mean, we were looking into just like we have, let's say, a feature vector or feature numbers, 1 and 2 numbers for just the truck, right? Where we use categorical data like a brand or type or engine size or whatnot. And we do kind of an encoding. For me, it feels like an encoding. We just encode it into a 2-dimensional vector, basically. And that represents this truck, right? And we can do similar things with people. You have to be a bit careful. Let's say one thing that is rather simple, I think, and that you can use is, let's say, how many kilometers has this person already driven? You know, that's just an experience number. It's not even the age of the person, right? It's really just information about the person on his job or on her job. Or let's say other things would be what type of training and how long ago has this training been, right? What I don't like to take are, let's say, gender or nationalities or things like this, right?
Definitely not.
Yeah, but this is obviously data that the people, the fleet owners, kind of have and want to give us, and we're like, nah, rather not. That's going the wrong way. Okay, but in general, I want to say we're looking into that. It's not as simple as with trucks, right? With trucks, it's easier to.
Of course.
Yeah, and with people, it's more difficult.
Can you give people like actionable tips? Like, Alice, you are really efficient when you're driving on flat ground, but if you when you drive on hills, you aren't as efficient as Bob. Can you learn from Bob, or can you learn from a training?
Yeah.
Can you teach Bob to do this thing, which he doesn't do very well?
Yeah, of course. I mean, this is getting now really into the intricacies, right? Because now, yes. So one thing is, how do I find whether it's hilly or not? Yeah, okay. But of course, it's, I mean, doable. I can, at least what I can do is I can can compare them also on sub trips, right? I can say, okay, let's compare them only uphill or only downhill or something like that, and we can learn from that maybe, and saying at least one is better here, one is better there. We are hoping, but this hasn't materialized yet, we are hoping to also get from the data. Remember I told you that we see which gear they're in, but we also see the gas pedal, how much, so that is kind of that's unique to the person in some sense, right? That is really the driver's influence, how the pedal is moving, right? And so and also the gear, kind of, that's the decision of the driver. At what point do I shift the gear from this to that? And so we are hoping to find something in these kind of indicators that are really personal to the driver, right? Because the problem is always, how do you separate the truck from the driver, from the trip, from the weather, and so on and so forth, right? How can you really make sure that you assign it, that you pinpoint it to the correct one? Maybe it was just the weather that was the difference, yeah, and you have to assign it to that. So, but yes, this is difficult, but we have a neat machinery how we can look into these things.
Awesome.
Mm-hmm.
I have a sort of different branch of question, which is, does Trax also work on platooning? Because I saw this on your website. So platoon, for those for those in the audience who have not heard this term, platooning refers to efficiency mediated often by autonomous vehicles that are able to drive basically in each other's slipstreams to do things very efficiently.
Yes.
Is this something that you're also working on? I don't mean to force you. I think it was on your website was very good.
No. Okay, no, that's okay. So yes, you very well explained. So that's a platoon, and that was, let's say, the original founding idea. And still, maybe just to make sure that there's no misunderstanding, we haven't been and will not be working on the actual platooning. Okay, that is not like actually trying to get the trucks drive together, because there's many technical challenges there as well. It's just not what we're doing. However, when you think about this whole platooning idea, you have to think about, why would the first guy go in the wind so that the second guy saves? Yes, and in worst case scenario, they're competitors. So the idea was, okay, the only way that works is that the second guy gives the first guy money. And then it's the question, how much money? And here you need to be able to predict fuel consumption in the wind, even if you were driving not in the wind.
So this is sort of like the precursor to this. It's like the counterfactual. What would happen if you did this? What would happen if you did this?
Yes, and that's what we're doing, right? As I explained in the whole idea of how do we measure efficiency, that's basically what we're doing. We're taking Alice on her red truck, going on the trip that Bob with his blue truck went on, right? And trying to predict on that. So we're trying to develop a core technology that is useful for other things as well. And the original founding idea was in this platooning idea. However, at least in Europe, I don't know how it is in the USA or in North America or anywhere else on the world. In Europe, it is also still a legal issue. It's not so simple, and the countries have different regulations maybe. So yeah, and obviously we are not we are a company, right? We cannot we have to find products now and not in, let's say, 2, 3, or maybe 5 years. So basically, it's a bit of a reuse of the same technology, right? Or we develop the same technology that can be just used for different things. And
that totally makes sense.
Also, yeah, cool.
I have one more question, which is, again, I mean, I don't know if this is, maybe it's slightly more technical, but if you're working with a particular client, and they are implementing your suggestions, ideally, do you run into an issue where you aren't having enough exploration, and you're just sort of, it's like an exploration versus exploitation trade-off? If you are only getting data based upon your predictions, do you get enough data that's not based upon your predictions? Or does that make sense? Like,
okay,
data
I think
you can actually learn from, because you can't learn from data where you are yourselves making, like, changing what that data is. Or there's a limit to how much you can learn from it.
Okay, I understand it. I feel like it is not so relevant in our situation. And let me try to explain why. By us telling our client to take Alice on the red truck on, the north trip, we do not influence the data so much, right? We just influence that obviously we only get Alice and that truck on that trip, but still Bob on the other truck will go on the other trip, right? Somebody needs to go on the trip. And we only influence which one goes.
Of course, I guess I was just meaning that, maybe there's a sort of an optimum that the algorithm has never found. And so it always, for this particular trip, one time Alice did it better than Bob. And so ever since then, the algorithm always says, Alice, go on that trip, even though that was just an anomaly. And Alice was just particularly awake that day or something.
Yeah. Okay. I mean, you never know, right? Whatever's going on in the neural nets, you're not 100% sure. But I think the setup is really different because these trucks collect data, let's say somewhere between every 60 seconds and 5 minutes. Okay. So you get your trip sliced, right? And that I think it's just very diverse data. And even though, I mean, obviously, if Bob always goes with the same truck on always the same trip, then I also felt that the data is biased. But if it's a bit, more random, going different ways, obviously, I mean, trucks are going only in Germany. I don't know how much I would trust them on the simulation in the US, honestly. But I see that point, obviously.
No, of course, that absolutely makes sense. And, data distribution changes are always going to kill you. But there are enough trucks in Germany. If you're able to make trucks in Germany more efficient, that is fantastic win just by itself.
I think that's good for us. Yeah.
Fantastic. Well, thank you. I guess the last chance for anyone to ask any questions, but thank you so much for joining us today. I really enjoyed this, and. For everyone who joined in for this, our next session will be in some number of minutes. I'm working out how many minutes that is. That will be in 25 minutes with Sylvia Terra. So that's at the half hour in most time zones. And thank you again, Dr. Daniel Rohr, for joining us and talking about tracks.
Thanks a lot. Yeah, thanks a lot for the invitation. I enjoyed it. Thanks for the questions as well. Everybody have a great day. Bye-bye.
Have a great day. We'll be back with you soon.